Our next speaker, he started Australia's first open access molecular biology hacker lab, as you do. I'm sure we'll find out more about what that actually means. He was involved in one of the first legal cases on cyborg rights because he gamely inserted one of those transport swipe cards into his hand. And some transport authorities had some problem with that. He's been civically active. He's run multiple times as a candidate for the Science Party and for the Flux Party. Currently, he's running startups to help stop climate change and deforestation. He's here to talk about accelerating human evolution with transhumanism. Ladies and gentlemen, Meow-Ludo Disco Gamma Meow Meow. Please come to the stage.
Thank you very much, Mark. Every human used to spend all their time doing nothing more than surviving their own environment. But humans have one advantage over other animals. Instead of just evolving to adapt to their environment, humans can evolve their environment to adapt to them. Since the discovery of fire and the first simple shelters, humans have adapted to colonize every continent and habitat on Earth. We're now living permanently in space aboard the International Space Station, and we're making plans to colonize Mars and the Moon. And almost no human now dies from their environment in the developed world. Sure, people still die from accidents, but overall we're living older and happier lives than we ever have due to technology. And as technology advances, we're starting to realize it's not just business as usual. Like the scythe on the end of a man's arm, technology used to be thought of an extension of ourselves. Now, things are changing. We're bringing that technology literally inside our bodies. This famous quote, "We shape the tools, and then the tools shape us," by Marshall McLuhan, maybe. When I was researching this talk, I actually tried to find the origin of this quote, and no one really knows who said it, but everyone just attributes it to this guy anyway. No one's even sure what the words are, so don't misquote me if you go and use this quote in the future, please. Okay, so when we think about technology, we might think about like robots or electronics, and while it's true, they are technology, they're not the only form of technology. So my background is in genetics, and my technology is life. At the moment, genetics is undergoing some really interesting changes. So we're modularizing and standardizing all of the genetic components so we can start engineering it. Now, one of these you may have heard of. It's called CRISPR. Has anyone heard of CRISPR? Yeah, so this is a really cool one. It allows us to do a search and replace in the genome. And these tools are really cool. Instead of just like muddling around trying to play with some genetic material, we can actually do some really targeted work that allows us to tackle some really complex problems. Probably the most complex of all being aging and death. So Groucho Marx once famously said, "I intend to live forever or die trying." And it's really cool. When I go and see my doctor, we have a bit of an argument about what the goal of medicine is. And I say the goal of medicine is to cure death. That's the end goal. And she says, no, it's to keep you alive for as long as possible. And one of these is a bottom-up approach, trying to treat all the symptoms and eventually cure the thing at the end. And I think the best way to approach this is just to cure death. Solve all the things, stroke, heart disease, all that can be cured. And people are actually trying to do this. So in Australia, Elizabeth Blackburn discovered a really funky thing. So this is a chromosome. The human DNA is basically like chapters in a book. So it's not just one long string. It's chopped up into chromosomes. And chromosomes contain all of our genes, but they also contain some other things. And one of those things is structural DNA, just stuff in there to allow the genes to be read. And right at the very end, because our DNA is linear, is a little piece called a telomere. And this enables the DNA copying machinery to attach. So if you think about having like a broomstick and grabbing onto the end, that would be like the DNA machinery latching on when it needs to copy. But it can't copy the bit that it attaches to. So every time a cell divides, the DNA gets a little bit shorter. That's a problem. Eventually, that would go down until it starts hitting the genes that we need to survive. And this happens in very, very, very old people. So Elizabeth Blackburn discovered an enzyme, a little molecular machine, that goes and just copies a little bit on the end of the DNA. So every time it gets shorter, it just gets longer again. But when you're 25, that switches off. And every time your cells divide, a molecular clock is ticking. And it's one of the key causes of aging. So why don't we just switch this back on? Some researchers in Spain in 2006 tried to do this with rats. When they gave it to middle-aged rats, they put it on a little virus and switched this gene back on. The rats got a 26% extension of life. To compare that, if that carried through to humans, current life expectancy in Australia is 82. That would take our average life expectancy up to 104. So quite a big change. And someone's actually done this. So I was lucky enough to meet Liz Parrish over in Texas 2 years ago. And she's the first human to be getting biologically younger. She's aging backwards, Benjamin Button disease. And basically, she flew to Colombia, made the same treatment that the rats got with a few modifications, treated herself with the gene therapy, and now when we look for biological markers of aging, so her telomeres, her cholesterol levels, blood pressure, they're all going down, and the telomeres are going up. So her telomeres have given unaged about 15 years. And all the data is online. I wonder if it's normally distributed. Okay, and this is what the virus looks like that puts it in there. I really love viruses, so I've always got to stick something in there. So these are called AAVs, adeno-associated viruses. Now, CRISPR and adeno-associated viruses are both trying to do the same thing, except CRISPR is only really useful if you're a single cell. Past there, you probably want something like this that can go to all the cells in your body and deliver the genetic information. Because even though CRISPR is really good at searching and replacing, it's not very good at getting into every cell in your body. Okay, so these are two mice. They are littermates. They're born at the same time from the same litter, and an experiment was done with them looking at senescent cells. So they're another thing that cause aging. They're basically cells that weren't doing what they were supposed to be doing, but instead of the body killing them off, they've just stopped. So they're kind of zombie cells. And it's better than the alternative, which is they might turn cancerous. But these accumulate throughout your lifetime. And it was hypothesized that maybe these are causing aging. So called senolytics. Senolytics are drugs that remove these senescent cells. So these cells actually secrete toxins into the cells around them. No detox diet is ever going to get rid of these, but very common antibiotics like azithromycin might. Now, I was a bit skeptical, hey. I'm like, do any of these cells actually do anything? Do they contribute much? Until I saw the next photo. So you have like this mouse Adonis on the right-hand side, and these are the same mice we saw before, and then you've got the Hunchback of Amsterdam over on the left, and basically the mouse on the left had a 10% extension of life. So that's pretty cool. We've got 26% from telomerase, and we've got 10% from senolytics. Things are looking bright. There's some other, I'll just briefly cover two more. So Aubrey de Grey, a very famous life extension advocate, thinks that mitochondrial DNA, the powerhouse of the cell, it might be responsible in some forms of aging. And really recent research, just 2 weeks ago, was talking about the methylation of genes. So when you're born, all your genes are switched on, and as you get older, they get switched off. And it's like locking a door and closing it. You can't really switch them back on unless you use something like CRISPR. And these are generally genes that are involved in cancer. but we might be able to switch some of them back on to increase our life expectancy. And this basically brings us to this key concept called escape velocity. So if we can have 26% with one treatment and 10% for another, we're starting to see a pattern that the further time goes on, the more that technology increases. So in the last 40 years, and from 1970 to 2010, we had a 10-year extension of life in our life expectancy. So every year that's gone past, we've added 3 months onto our life expectancy. And as technology progresses, we can imagine that it might go to 6 months or 9 months and then eventually a year. And once we get to adding 1 year for every year that passes, we will have hit this concept called escape velocity, where we're functionally immortal. We haven't cured death, but we're chasing it at the same rate it's happening. So this is a key concept in transhumanism. Oh, that's a good one, isn't it? Yeah. Slide transitions. Okay, so now we're going to move into the cyborgy kind of part of the talk. So all of us are transhuman. Well, I'm guessing most of us in the room are transhuman in some degree. Someone actually said to me today, Mark was like, oh, my glasses have broke. I'm no longer a transhuman. And he's right, because anytime we use technology to improve the quality of our lives, we're transhuman. We're better than, well, more advanced than a caveman. So vaccines are a really common way. We've patterned our immune systems with technology, enable us to survive longer. And anyone who has implant or a pacemaker or a hip replacement or any of these things, you're all definitely transhuman. Now, people don't really get upset when people get pacemakers, but it turns out they do if you get this implant on the right. Now, I have 3 implants in my hand, and it really provokes people. Anytime I'm in the news, there's hundreds of people quoting revelations out of the Bible to me saying I've got the mark of the beast. And I wonder why do people care if I get that implant but not this one? And I think one of the key aspects is about ability. So removing disability from someone using technology is generally considered a good thing. No one yells at someone on crutches because they're using technology. But if they had a mobility scooter and they weren't disabled and they were riding down the street, people might get quite upset. And this is because once you give someone an advantage over everyone else, people start to have tall poppy syndrome. So that plays into implants a lot. And we're going to see some pretty interesting stuff happening across the next decade or two. One of those things is, I reckon, is going to be in the Paralympics. So as technology gets better, we're finding that the Paralympics records are catching up to the regular Olympics records. And I wonder what happens on the day that a Paralympian beats a regular Olympian and how the world will deal with that. Because it's probably not far away. Or cyborg drummers. Okay, so yeah, just press the point a little bit more. So I constructed this experiment a little bit, which is, imagine we have a pill that increases your IQ by 40 points. How would we feel about giving that to someone with an IQ of 60? Or an IQ of 100? Or 140? And the way you react to that kind of explains how we feel about most of the types of implants and modifications that we're using. So I belong to a group of people called grinders. We advocate the use of technology built by ourselves to be implanted inside. So this is my friend Tim Cannon, who runs Grindhouse Wetware. We started a company last year making cyborg cows and using a modification of this implant, actually. So this takes the temperature from Tim's body, it Bluetooths it to his phone, and it controls the heating in his house. Very convenient. But every time he goes out for a cigarette, his wife complains because he gets very cold and the house gets very warm. Cyborg problems. This is a video of me using my implant at the train station. So it was very convenient. It enabled me to tap onto the train. I basically unwrapped the card, or a Mile Grafstra from Dangerous Things, modified an actual card and put it into a new wrapper and caused lots of problems with Transport New South Wales. But it was very convenient. I could carry a hamburger and a coffee, and I had a frictionless experience with technology, which I really enjoyed. You can get magnet implants, which is pretty cool. So these enable you to do things like feel for live cables behind walls, enables you to check fuses with your fingers, pick up screws you've dropped in the computer, and do party tricks at the bar for free shots, which I've seen on many, many occasions. Okay, and this is the final one. This is the North Star that Tim also made, and it's an aesthetic grind. So it basically is just LEDs, and it switches on when you put a magnet over the top of it. And it's tattoo parlors and piercing studios used to just use needles. Now they're using needles and thread. And I think we're going to see more of this as well. Okay, so this is Jan Sherman. Jan Sherman is a DARPA employee in America. It's like Defense Advanced Research. And she became a quadriplegic, so she volunteered to have a brain-computer implant put into her skull and into her brain. What you're seeing now is her controlling a robot arm with nothing more than her thoughts. This happens pretty quick as well. This whole experiment from implant to removal happened in less than 2 weeks. It's pretty incredible. This implant is called a Utah array. It's very small, has 96 electrodes. I'll talk about it in a sec. Very cool. Okay, so in 2010, some US researchers kind of used one of these Utah arrays on 2 mice. And they were going to see whether they could communicate brain to brain over the internet. They chopped off the top of the mouse's skulls, put these electrodes on, closed them back up, and they showed one mouse a light. If it saw the light, it had to hit a lever. But the other mouse saw nothing, and it had to know when the other mouse hit the lever and saw the light to hit the lever. If both of them hit it, they both got their prize. The prize was a drink of water, pretty crap prize. But if they didn't, if only one pushed it, they got nothing. And they were able to do it consistently every single time. It didn't matter how far away they were. They ended up trying it between rats in different countries, and they were able to do this. So and there was no training or anything like that. Their brains just instantly communicated with each other. In their suggestions, they said they want to connect more and more rats to create a rat organism, which I think is really exciting. Now, some researchers in Japan were looking at doing some... how am I going for time?
You're good.
Awesome. Oh, beautiful. Okay, so some researchers in Japan decided to do some research using EEGs. So it's basically a very simple brain scan with the electrodes. What they did was they would record people playing scissor, paper, rock with each other. And then they would take what brain scan corresponded to what outcome or what thing that was thrown. And then they could eventually train the computer to guess what the person was going to throw 2 seconds before they threw it. And the part of the brain they monitored was the Broca's area, the language area of the brain, and the person thought the word, and they could guess it. I thought that was pretty cool. They actually went a little bit further and started doing this by showing them pictures and then taking the brain scans and trying to work out what they were seeing. So they'd look at a whole heap of pictures, take the brain scan, then they could show them pictures, and the computer could guess what came out, what the person was looking at. So the top row of the next slide is what they showed the people, and then the bottom is what the computer guessed. It's a bit hard to see, but it's kind of freaky that the computer was so good at reading images out of their mind. I think this is pretty interesting when we think about how we might use this with like coma patients, or how governments might use it with people who don't want to give them information. So pretty terrifying. Maybe myself if I forget the PIN on my phone. Yeah. This is basically, the bottom is the same thing again. Top is what they showed the person, and then this is what the computer read out. So maybe everyone knows this stuff is kind of coming, but hopefully through my speech tonight, you'll realize it's probably a little bit closer than you think. I'm just going to zip through. So this is the Utah array that Jan Sherman had in her head. There's a video of it, a GIF of what it looks like going in. It's pretty terrifying. You'll notice it's rigid. These are all they're like proper needles, right? This one's pretty cool. This is a little bit further. This is basically the same kind of implant, except it has LEDs and a drug delivery mechanism. They just like load up the drug cartridge, and they can just Bluetooth give the rat that drug in its brain. They can also control it remote with a mobile phone over Bluetooth. Oh, I had a slide of the remote control rat running around, but it didn't make it in. I'm pretty excited for remote control rats. Like, I got a remote control car when I was a kid. I think it'd be much more fun to have a remote control rat. I would have had a much higher likelihood of going into genetics. Okay, so I'm just going to wrap up. This is the final kind of bit with Neuralink. Has anyone heard of Neuralink? Yeah, this is Elon Musk's big brain-computer interface. I haven't actually watched the video. I went and read the paper and then pulled this information out of there. So this is pretty groundbreaking. I didn't think it was going to be that amazing, but this is his go at brain-computer interfacing. This is a picture of Neuralink inside a rat's brain. You'll notice it has flexible filaments, and this is important because it allows you to dodge the vasculature in the brain, which causes rejection. It also has a USB-C connection, which is very convenient. So if you want to remote control your rat, and it also has a huge increase in the amount of electrodes. So the Utah array had 96 electrodes, and that was the standard. This one has 3,000 electrodes. It allows us to do things that we haven't been able to do before, and it's always moving towards this idea of uploading our consciousnesses to the cloud. Maybe something like this. Like this. Boom, there we go. But it's going to be pretty small. This looks like something that you'd see an iPhone user wearing walking down the street. It will have multiple implants that go in, so I'll have more than one of the lots of 3,000 electrodes. And this might be going into humans in the next 2 years. They're calling out for people. So if you're game, get in contact with Elon. I'm not. I'm going to wait for the beta testing to be over. And if you have a look at B is the 3,000 electrodes. They're as fine as a piece of hair. The problem is it's very difficult to put that into a brain because, as you know, if you put a piece of hair onto the surface of something hard, it's going to bend. So he basically invented this giant machine to put it in, and it does it all automatically. And it's magic to watch this thing. So there you go, just inserted an electrode. He reckons within 2 years, we'll be browsing the internet using this, but if we remember back to the rat experiment, it won't be much longer before we're connecting our brains to each other across the internet. And finally, that's my second last slide anyway. Finally, we can upload ourselves to the cloud. Thank you very much.
Big hand for Meow. Thanks very much. I reckon we've got time for a couple of questions. I'd be amazed if there weren't any. Yes? Here we go.
You mentioned that you've got 3 implants.
Yeah.
One is the transport card. Would you mind telling us what the other 2 are?
Yeah, so the other 2 are reprogrammable, so I can change what's on them. At the moment, I have my business card on one and Pokemon on the other one.
Maybe it's a Mac PC thing, I don't know. Any other questions? That was a great one. Here you go, Karen.
What about the ethics and ethics approval and all that jazz that you haven't mentioned about?
Yeah.
Who's controlling all this stuff?
Yeah. So one of the reasons, the grinders, we have different ethical problems to corporations. So we're big on open source, but we're not necessarily big on following FDA regulations or something like that. But I think we're necessary, and I think that most of the people in this grinding scene are big on democratization of these technologies. So especially with things like life extension, there's always a worry that maybe it will be heaven forbid, Rupert Murdoch living forever, and everyone else dying. But I think that one of the great things about science is you can always get the paper. And if you have things like open access molecular biology laboratories like I've set up, you have the means to be able to go and replicate these things. I want to do life extension gene therapy to myself in my own lab.
All right, transhumans. All right with you, Meow? We'll leave it there.
Beautiful.
Thank you very much. Big hand again for Meow.